Hi, and welcome to Online with an Architect. We're back with example architectural decisions. Very happy to have my colleague James Worth with me. Welcome, James.
Hey, Josh, how's it going?
Very good. We've got a great topic today, actually, one that's near and dear to both of our hearts, which is vSAN architecture, as well as resiliency and day two operations. So quite excited to present this one with you.
Sure. Yeah, let's get into it.
Let's do it. So for those of you who are watching on a big TV, please subscribe. Here is a QR code to make your life easier, and let's get on with it. So today we're going to talk about three decisions. We're going to talk about vSAN architecture, so OSA, original storage architecture, versus the express storage architecture, or ESA. We're going to talk about failures to tolerate configurations. And then the third topic, which I think is the one that's most neglected, is the configuration for resiliency and day two operations. So let's jump straight into OSA versus ESA.
So, yeah, OSA versus ESA. You have a bit of a history of doing some analysis and sharing your thoughts on vSAN and various topics, don't you, Josh?
I do, yes.
And there has been that change recently of ESA. And so it's almost like it's a new product because they're fundamentally changing the operations of the underlying storage and how it all fits together. And so a lot of your analysis and discussion and items that you've published is likely still relevant, but only to OSA, or the original storage architecture. Would you say that that's true?
That's exactly correct, yes.
And so the new architecture, which may as well be a new product, is completely different. So it's almost like it's a different vSAN. It may as well be a different product. So if in the past you've made some comments about OSA or about vSAN and said, oh, there's this problem or there's this issue or this risk or some other downside to vSAN, that's not necessarily relevant to ESA because of these major changes, but it's likely still relevant to OSA. Would that be an accurate
it's exactly
overview?
Spot on. So definitely OSA as an architecture I've been critical of in the past, especially with the early releases. And as OSA has been enhanced over the years, some of those issues have been mitigated. But certainly ESA is like you say, it really is a new product. It's a new architecture. And that's why this first decision, I think, is quite an interesting topic because there's a lot of things to consider.
Well, you say it's an interesting topic. I personally think this is a bit of a non-decision, really, because if you have the hardware where you can run ESA, you're never going to choose OSA. So it's basically what hardware do you have or what hardware can you afford? That dictates what you're going to decide. But if you are at the point of making that decision of which hardware to buy and why, then yeah, you certainly want to look at these two options.
I think you've given us a good spoiler there. I like it. And look, I agree completely. I think ESA is definitely the way to go. That's VMware's position as well. But certainly as architects, we see a lot of value in ESA. So, for the listeners out there, we've put together these problem statements. And this is, very generic and high level. But the idea is to show you an example of a decision, why we've made it, what are some of the pros and cons and things like that. So here we've got Acme Corporation are trying to decide what their strategic platform is going to be for their on-prem data centers. And they've decided on VMware vSAN, which is a very common choice. And we're talking about OSA versus ESA. So which one is the right one for the customer? So
this first, sorry to cut you off there, but some of these requirements here, we're trying to make it look like a decision where, you might actually choose OSA. So, if you're trying to use older hardware, for example, this could be a requirement that a customer would have. And in the case of when you're making a decision of what sort of software you're going to run on top of that hardware, obviously it needs to be compatible. So that's important. Also, and number two there, of course, highest possible availability. And that may well conflict with using old hardware. But yeah, that's many people are going to want to have very high availability. And as we move down the list there, 24/7, 365. This one, I mean, we always talk about this type of availability, but I think nowadays most companies have some sort of online presence. And if you're running something online, particularly if you're in some way international, you really have to have 24/7 operations. You can't have a change window anymore. So that's incredibly important to think about that.
Yeah, indeed. And I think the last one, scalability, is always something that can become an issue very quickly and be a very costly one. So thinking about where you're going to go after your initial decision, after a year, 2 years, etc., is very important as well. So just a couple of requirements for us to really go off and map back to this decision, which, as you say, is a little non-decision, but nonetheless. So I think the first constraint is a great example of why people will move to either new hardware or stick with OSA, which is the existing hardware is not a vSAN ready node compatible with ESA.
Yeah, and that's one of the very important distinctions with ESA and OSA, which, as we've already identified, could basically be two different products. The hardware requirements are extremely strict for ESA, and that's could definitely be a negative. I mean, obviously there are certain positives that come from having a very strict HCL, but on the other hand, it means that you're extremely restricted with what you can run this stuff on.
Yeah, so certainly reusing existing hardware is going to be difficult in most cases, but certainly to your point, it can be very valuable to have a strict HCL. You get a lot of resiliency out of it, very predictable, consistent behavior, your upgrades work, all this kind of stuff. So I think
you have some experience with software that had a very strict HCL in the past, don't you, Josh?
Absolutely, yeah. So look at Nutanix. Nutanix for many years only sold appliances, and I think one of the advantages of that, which I spoke with Cesar Reddy, actually CTO at VMware, about in an earlier episode, was I feel like that's a great value. So I actually don't see vSAN ready nodes as being a negative or too much of a constraint. I see
except
it
if you
value.
take the cost into consideration.
Yeah, like you take the cost. In isolation, yes, they might be more expensive than reusing existing hardware. But then when we talk about the total cost of ownership, sometimes when you buy an appliance and it delivers that outcome and it just works, that can actually save you money. So
certainly.
It's there's certainly different ways to look at it. So again, if existing hardware is available and even if it was supported, it may well be close to end of life. So this is something that I don't think I would want to recommend to a customer to use hardware that was coming end of life, because they would probably have to migrate off quite quickly, and that's rework and things like that. So
yeah, potentially. But to take the side of OSA again, not everybody has an unlimited budget for software, and part of being an architect is making good decisions that are also cost effective, because ultimately what you're trying to do is run a successful business. Successful businesses need to make money, not spend all their money on their IT infrastructure. And it's easy to be an architect that just says, buy the most expensive thing all the time. That doesn't really take a lot of talent. So, I think sometimes you've got to be careful about just saying, just buy this thing because it's the best. Like, sure, okay, it's the best, but is it really going to be a cost-effective solution?
Yeah, indeed. And the other thing with ESA is it's only supported from vSphere 8 onwards. So obviously, if you're a customer on vSphere 7, then you are going through a transformation activity or an upgrade phase to get to version 8, regardless of whether you went with OSA or ESA.
Yeah, and that's another potential consideration. I think we're at update 2 now, but because this has been such a monumental change in architecture, you're effectively at version 1 of ESA. So at the very least, I would want to have an extremely robust testing period before I'm going to put business critical applications on this stuff, because it is so new, it's so different. This is not version 8 of vSAN if you're running ESA.
Yeah, absolutely. And I think to VMware's credit, that's why they've made the vSAN ready nodes the requirement for this initial release, to ensure that the outcomes are met. So I quite support that decision. And vSAN Max, which is a new capability, is only supported with the ESA. So if customers are wanting to scale out with a storage-only cluster, then ESA would be a constraint in that case.
I think vSAN Max is kind of funny because it's like, let's use HCI, and now let's turn our HCI into shared storage. It's kind of like
Yeah, it's a whole disaggregated piece, and I think there's pros and cons to it, of course, and that's definitely a topic for another day. But I think it's good to have the option, regardless, even if it's not something that we necessarily love. All right, so let's move into some risks. So these are pretty obvious risks, but again, things we should always consider and understand the impact of. So we've got the obvious ones: the single node failure, single storage device failure, single NIC failure, all these things which really shouldn't have any impact to our production workloads. And then we've got the dual concurrent failure scenarios of the same devices, so nodes, drives, and potentially a network connectivity loss. So, and the last one I think is very important: is what is the impact to a business critical application during a maintenance operation or a failure, in fact.
Yeah, so if we're thinking back to our requirements before, we're talking about a 24/7 operation. We don't have change windows. So, what's going to occur? Is our performance still going to be there while we're doing maintenance, while we've got a node down, or we're doing some other type of maintenance?
Absolutely. And for those listening, this is a key point that we'll be covering off in the justifications for the decision. So we'll obviously be linking back to all these risks and requirements, but this is one that we cover off quite in depth. So our assumptions, not really many assumptions, and ideally you shouldn't have many when you're making a good decision. So if you have a lot of assumptions, you really should be validating them before you go too far into a project. We're going to assume vSphere 8 being the latest release. Update 2, as you mentioned, is out. So we're assuming that's where we're going and that we're remaining on premises at this point. We're not using one of the multi-cloud solutions at this stage. So our options, obviously it's OSA or ESA, and another option, although we're assuming we're going to version 8, so it's not really applicable, which would be staying on vSphere 7.x on vSAN OSA, but we're really focused on the top two in this case. So to everyone's surprise, James, what is our decision?
Yeah, they're going to use express storage architecture. Oh, there you go. How about that?
I would never have guessed. So Acme Corporation is going to use ESA. All right, let's dive into why.
Why are they going to use it?
Exactly. Now, it's a lot of words on this screen, James. Walk us through it.
Yeah, well, the ESA, as we've mentioned, is a complete re-architecting of the way the underlying pieces are grouped together that make up vSAN. And that, of course, eliminates the disk group. And the disk group was one of the sources of a lot of potential problems when you're talking about single device failures and how they impact the disk group. So if you lose the cache disk, for example, that's a huge problem. The boundary of failure is greatly reduced, as we've mentioned there. So, and I was alluding to that as well. When you're losing a cache disk, it's less impactful.
I think for those listening, if you're not familiar with disk groups, you've got a cache drive and capacity drives. So if you've got, say, one cache drive and then you've got, say, 7 capacity drives, which is the maximum, and you lost your cache drive, you would lose all 7 drives. That whole disk group goes offline. So that could potentially be, tens of terabytes of data that needs to be resynchronized. So in ESA,
it makes it really hard to recommend OSA for anything because of that reason.
Yeah, for sure. And also just, data reduction, data efficiency technologies, compression and deduplication being tied to a disk group, and the failure scenarios impacting the disk group quite significantly was also something I was quite critical of in the past, that the impact is, too high of a risk for the reward of the data reduction.
Yeah.
So I think the point 3, actually, I'm quite interested in, which is when we reduce that boundary of failure to a single disk, effectively, or a single NVMe or flash device, it means that, we're reducing the chance of a double failure occurring because the resynchronization will happen faster. So if there's less data to resynchronize, it can happen faster, which means you're back to a resilient state to be able to therefore tolerate subsequent failures. So it's not just about the initial impact, it's how quickly we can recover, and also the performance impact of a resynchronization on any platform is reasonably significant because it's a lot of data to be copying around the network. So if we can make it so that we lose less data, there's less data to rewrite, less impact, faster time to recover that resiliency, all these things are great. So ESA architecturally, from that perspective, has a huge advantage.
Yeah. And on the bottom there, we've got vSAN Max, which we can use to expand the storage.
Absolutely. And I think one of the requirements we talked about at the start was requirement 5, which is we really need consistent performance 24/7, 365. So one of the things with OSA was when the writes come in, they hit that cache drive, which is a single cache drive. If you have multiple disk groups per node, you might have multiple, or you would have multiple cache drives. But effectively for that disk group, you're constrained by the performance of that one cache drive. So your write I/O might become a bottleneck due to the destaging operation going from cache to capacity. So eliminating that concept as well helps you deliver consistent performance because all the disks are used for that activity. So I think that's a great move as well.
Sure. Yeah, and sorry, on the vSAN Max there, I still kind of think like if you need to scale out your shared storage, then you could attach some shared storage. We've been doing shared storage for years, so if that's what you need, you can buy some and use it. But there you go.
Absolutely. All right, so there's more justifications here because it's a very very good decision, and I think it's really important to highlight the advantages actually of any platform that you're doing, both to educate your customer, or if you are the customer, educate your team on why you're doing things. So just simply mapping the fact that we've mitigated risk 1 through 6 by reducing our boundary of failure is something that's shouldn't be overlooked. That's extremely valuable and helps us achieve that business outcome of increased availability, increased performance, and just lower overheads in general.
Sure.
So point 8, this one is quite cool actually. So by eliminating the cache drive and disk group construct, we actually get more usable capacity. So I really like this one because the new architecture with ESA is not only giving us better performance and better resiliency, it's giving us more usable capacity, which is great.
Yeah, because you don't actually get to use the capacity on the cache drive. It's just cache.
Yeah. So, I mean, this is like a win-win-win for ESA. So, doing an example in an upcoming decision, the ESA vSAN Ready node had 12.8 terabytes usable, assuming we were using RAID 5. Whereas if it was OSA, it only would be 10.24. So that's about a 25% advantage in usable capacity. So obviously this is great from a capacity perspective, but that reduces your cost. So there's a lot of advantage there. One of the things actually that I really liked as well, which is going quite into the weeds, but I think it's worth covering, is with ESA, the compression algorithm has been optimized as well. So previously, a 4K block would be compressed to 2K, or it wouldn't be compressed with OSA. But now, ESA is going to compress down to 3 or 2 or 1. So in some cases with OSA, unless you're getting 2-to-1 compression, you would get 0. Whereas now, you can get smaller incremental savings with compression. So I think that's quite good and maximizes storage capacity. So that's a win.
Sure. And the requirement is just eluding me, right? Sorry, the setting is eluding me right now. But was it if you enable compression and you lose a disk, you lose an entire disk group with OSA? Was that
was with OSA, yeah.
Yeah.
Certainly that's a resiliency risk. So you're getting compression, you're getting some capacity efficiency, but you're increasing your risk of impact and data loss. So that certainly was something I was critical of.
Yeah, so for OSA, you would almost not want to enable compression because you're exposing yourself to that huge risk.
Yeah, I think it's a risk that's definitely not insignificant. So,
to put it lightly,
yeah,
not insignificant. Yeah,
for sure.
All right.
I mean,
Maintenance mode.
Yeah, mitigating risk, right? This one, I love mitigating risk, and ESA has enhanced durability during maintenance mode. So basically, if we're using RAID 5, it's going to ensure the write operations are continuing to operate as normal during the maintenance function. So even when the object is unavailable, it's going to write it somewhere else. So ensuring write integrity during maintenance is fantastic. Again, that's something OSA wasn't doing, and ESA is stepping it up. So great job, VMware engineering.
Yeah. And reusing existing hardware. We can't reuse our existing hardware, Josh. You're making us spend more money. Sorry, you're making Acme spend more money. So
Yes.
why is Acme spending more money, Josh?
Well, we have a constraint. So right at the bottom in tiny little writing, we've got constraint number 2, which is unfortunately our existing hardware is not on the HCL for ESA.
Yeah.
So
not much hardware is.
Yeah, we've got a lot of advantages here, as we can see, but unfortunately, there's a bit less flexibility with hardware. So I think the other thing which is important with RAID 5, RAID 6 in ESA is the fact that it's almost the same performance as failure to tolerate 1 with mirroring.
Yeah.
Which is great. Obviously, if we can have more usable capacity and have roughly the same performance, yeah, that's a huge benefit. And that basically comes from ESA's log structured file system. So that's a great improvement as well. And the final point, of course, is we can scale with many options, HCI Mesh or vSAN Max. So there's plenty of options there if you wanted to choose vSAN for all those, or like you rightly mentioned, you could attach some shared storage as well from whoever your favorite vendor is.
Yeah, so it sounds like, having gone through the requirements, constraints, risk assumptions, and then justifications, that vSAN ESA, if you got the budget for it, pretty good product. Pretty good solution.
Very good. Yeah, very good product. So I think it's
leaps and bounds ahead of OSA. Really takes away a lot of those old criticisms that we still had of OSA.
No, absolutely. And I think, that's a credit to Sazala and the team who went through, identified what they wanted to improve and delivered that product. So if you didn't listen to that episode, everyone, Sazala Reddy, CTO at VMware, and I discussed ESA in depth. So please go and have a listen to that.
But also bear in mind, it's effectively version 1 right now because of this huge change in the way it all operates. At least that's what I'd say. Version 1, update 2.
Yeah, it's certainly newer, but definitely from speaking with Sazala, he inspires my confidence that it's a reliable product. They're running it at multi-petabyte scale in multiple environments, and obviously keeping a very close eye on it. So I think we're pretty safe
no doubt
on this route.
Yeah, and that tight HCL certainly de-risks using a newer product.
Absolutely. All right, so implications. So we've touched on this a few times, and we'll say it again. The HCL for ESA is way more restrictive than OSA for very good reason, but nonetheless, so we are purchasing new hardware, which, to James's point, poor Acme Corporation has got to shell out some more money.
But thanks to the excellent work that mostly you and partially I have done here, they've got excellent justification for doing that.
That's right. I think they do. So there's no direct upgrade from OSA to ESA. I don't really think this is a big deal because you can simply vMotion across. It's not really a big change. VMware's got all these great ways you can migrate. So this is really a pretty insignificant one, but still worth mentioning. But point 3, actually, I sent out a tweet about 5 years ago, maybe 2018, something like that. I looked it up the other day, and I said that deduplication was one of the most overrated features in the storage market, and it's mostly smoke and mirrors. And while dedupe does have some genuine use cases and is very good in certain cases, it's really oversold. And my opinion was when I worked at Nutanix, and my opinion now, and when I worked at IBM prior to that, it hasn't changed. It's an oversold feature, and deduplication is actually not supported in ESA. And what I would say to anyone considering this as a problem, I would say it's insignificant at best. You've got compression, you've got efficient storage with RAID 5, you've got great performance. I don't think this is a real problem, because you've still got, intelligent snaps, metadata clones. You've still got all these things that give you efficiency. You just don't have inline or post-process deduplication.
I think the theory is good that you've got a lot of the same operating systems on your storage. So why have the same storage duplicated so many times? But if that's really the case, if you really do have so many operating systems that are exactly the same, you're better off using clones and not, duplicating the data and then using processing power to deduplicate it. Again, just don't duplicate it in the first place if you really do have operating systems that are exactly the same.
Yeah, absolutely. And for things like VDI, people would argue, oh, that's a great use case for deduplication. I would say the opposite. Why are we duplicating it in the first place? So
yeah, and most of those implementations would use link clones for that reason.
Yeah, absolutely. So there's plenty of cloning technologies out there that are very efficient. So I think this point is a bit moot. So I wouldn't worry too much. The deduplication implementation in OSA was also bound to a disk group. So it meant that if you had, say, 4 disk groups on a host, you could theoretically have 4 copies of that data on every host in your cluster, because of the boundary for deduplication. So if you're comparing dedupe on OSA to ESA, that the benefit's probably negligible towards OSA, and the overall capacity advantage of ESA, I would say, far outweighs this one very small implication.
Yeah.
And obviously, compression only for ESA goes without saying. And then ESA is flash only, which
flash only. Yeah,
I think it's pretty negligible as well. Everyone's pretty much going flash anyway. So yeah, it's pretty cost effective.
Yeah, unless in all but the highest capacity requirements, you're going to go with flash for all storage these days, I think. But if you're doing things like archiving and backups, then you probably have a separate solution for doing archiving and backups anyway.
Well, I would definitely think so. I mean, certainly, regardless of what your primary storage is, I would always recommend using a different product to store that secondary or tertiary copy of data. Yeah. So there's lots of reasons for that, which we will cover in future episodes. So looking forward to covering off that as well. So related decisions. So this is something that's important to consider if you're an architect or you're trying to make some decisions. What else do you need to consider when you've made this decision? So things we're going to cover off, obviously, on this episode. We're going to talk about failures to tolerate. We're going to talk about day 2 operations. We're going to talk about, in the future, the node choice, so vSAN-ready nodes, cluster size, networking configuration, and much more. So very important that when you make a decision, you know all the related decisions, you make them, and then you cross-reference them to make sure they don't conflict with each other. No point making a decision in isolation. All right, so that wraps up our first decision. Stay tuned, and we'll jump straight into the second one.